going on, everyone? My name is Johnny Bandon, and I'm the CCNA instructor for this CCNA video series. In this video, we're going to go over static routes. So this is going to be the lecture portion of static routes. It's going to be pretty quick because we just got to touch on the static routes that CCNA exam objectives want you to know about, and there's really nothing too deep about them, right? These are just an administrative way for us to tell our routers where to send traffic for a destination. And this isn't a dynamic routing protocol, so the configuration is generally always the same, right? With the different static routes we learn about, we'll learn how to configure different things, and the syntax is always the same. So let's jump right into it. So a static route is an administratively configured route to any destination network. So static routes will not dynamically share information with neighbors. That's not the point of static routes. This simply just tells a router where to send traffic for a destination prefix, right? You tell it where the exit interface is, where the next hop is, if a destination IP needs to go out that router. So if user needs to reach this area, go this way. That's essentially the logic behind a static route. I can write that out. So if a blank, right, variable here, needs to be routed, go this way. And that's what a static route is. So you can see in our image right here, we have a default route out. So this router right here, let's say it's R1, is sending all traffic out its gig 00 port out to its ISP. And this is actually a stub network, which we're about to learn about. So let's go over some differences between dynamic and static routing. We're going to go over the major ones, right? So with dynamic routing, obviously it's going to be more resource intensive. It obviously scales a lot better than static routing because you need a static route to every destination you need to know about. So that's going to be real complicated when we get into our large enterprises. And then a dynamic route adapts to topology changes. Where with static routing, just the opposite, right? With these three major ones right here. An administrator always has to adapt to a topology change, right? Because a static route is administratively set. A static route is really suited for those simple topologies where you have maybe one neighbor or you have one default route out. All you need is one static route command and you're good to go, right? And then there's no extra resources needed because static routing doesn't have any algorithms, right? It doesn't have anything to take into an algorithm and execute on, right? There's no lead state database with a static route. Okay, now let's go over the different types of static routes. So we're going to go over 4 different types here. We have a default route, floating static route, and a host route. So a default route is going to be on a stub network. And what a stub network is essentially a router with no downstream neighbors, meaning this is the last router, this is the last demarcation point for that routing domain. The only connection it has is either to its hub or to its ISP. So in this scenario, we can just use a default route because there's only one path our users down here can go anyways, and that's out towards the ISP or just local here. So we can just have a default route out. And then we just have what we call a regular static route, where we have this network and this network separated by these two routers. And R1 wants to route traffic for its users over to R2's users here. So we create a static route. And then since we need reachability back, R2 does the exact same thing, creates a static route so that its users here can reach R1's users. And then a floating static route. This is essentially a backup route. So a floating static route should take over if the primary route, which is typically a dynamic routing protocol, fails. This floating one will take over. And we accomplish this by setting a static route with the same prefix as the dynamic, but with a higher administrative distance. So in this scenario, this backup route to OSPF, we would create a static route with, let's say, an administrative distance of 111, because that's one higher than OSPF. And then we have this host route here. What this is a very specific route. So essentially, let's say R2 also has a server here that's 10.10.10.4. Instead of making a static route to the whole network, we just make a route just to this exact host. So it would be IP route to this host for this network here. Okay, so the default route, the stub network. So a default route will match all IP traffic exiting the router. So we use what we call quad zeros for these default routes. So any traffic destined beyond its own LAN is going to use that default route. Okay. So a stub network is when there's no more routers or routing information to share downstream of a router, meaning it ends right here at our users. And the stub networks you're going to hear in all kind of different routing scenarios. OSPF and ERJRP also have stub configurations. A host route. So a host route is a static route that will route traffic to a singular host. So let's say there's multiple paths to reach a server. So right here we have R1, R2. Its primary route is this gig interface 00 here. So it's routing towards this subnet via this primary route here. Now, let's say someone asks you to route all traffic to this web server here via the secondary interface, but we just want traffic destined to that specific web server to go on the secondary. Well, we can accomplish that by a host route. So we can see here our syntax is for static routing, which we're going to learn in the upcoming slides. We're saying we're just routing to this host, and we can see it's just a singular host by this /32 subnet mask via our secondary route here, our secondary path here, gig 01. So all traffic destined to /27 is going to take the primary unless this router receives a packet with a destination IP address of .0.3, then that's the only traffic that should be coming across gig 01. And that's what we call a host route. And then floating static route. So like we already discussed, the floating static route is just a backup to our dynamic routing protocols. And we accomplish this by not using a more specific prefix and just by raising that administrative distance higher than the AD of our primary dynamic route, which would be OSPF. Okay, now let's go over the syntax. So static routing syntax is always the same, right? So it's going to be IP route, which is essentially telling that router, hey router, I want to route traffic for this network, and we need the subnet of that network. And when I want to reach this network, I need to go to this next hop, or I need to send traffic out this exit interface. And that's a static route. And optionally, you can also do the distance command where we can add like an administrative distance. Okay. So again, hey router, I need to route traffic to this destination network. And to get to that destination network, I need to send traffic to the next hop IP address. So next hop. And or this exit interface. So and or, right? Some logic here. We can either just put the exit interface, or we can configure both the next hop and the exit interface. And we're going to get into some differences of why you would use one or the other during our lab. Essentially, let's say you have a next hop IP that changes. Maybe the next hop IP is an ISP, and that provider edge router IP address maybe changes. Maybe you're set up on DHCP. Well, maybe in that scenario, we just want to use the exit interface. Now, let's say we control a routing domain and we always know the next hop and we always know the exit interface. We can configure both, and we're going to get something called full recursion. Okay. So that's just a couple scenarios of where you'd want to do one or the other. And really for our labs and in real world, just do something that works, right? I mean, obviously, if you know the exit interface is going to change, but you don't know the next hop IP because that's controlled by another organization, that's a demarcation point. Just choose the exit interface, right? So verification. So we can verify static routes by the show IP route command, which is going to show us the routing table, which we're all Going to go over this more deep in our static routing lab. And then really that's all the verification we need for static routes. Well, we can also do a show run command to see what's configured in our router. And we're going to get into that in our lab. So I want to thank you guys for viewing this static route lecture. Stay tuned for our static routing labs, where the first lab is going to be very basic. In our second lab, we're going to configure those floating static routes, those host routes, and the default routes. So I want to thank you for viewing.